In the previous class, we have studied the interference, basic idea of the interference of light and wavefront, definition of wavefront. So in the today's class, we are seeing the descriptive of wavefronts. What are the types of wavefronts and what were the definition of wavefronts and the properties of wavefronts. So first of all, wavefront. So in the previous class, we are seeing the definition of wavefront. It is also known as the wave surface. Okay. So wave surface or the wavefront. It is the wave surface or the wavefront is the surface of all neighboring points which receive the light waves from a source at the same instant and are in the same phase. That means the surface where the light waves receives, and there is a neighboring points, means there is a points wise direction, points wise surface where the light the waves receives. So that type of surface is known as the wavefront. There are three types of wavefronts. First is the spherical wavefront. Spherical wavefront, this is the source of light. So this is the spherical wavefront. Okay, so this is the wavefront, and this arrow is known as the wave normal. The definition of wave normal, see you in the next class. Okay, wave normal. So this is the diagram of spherical wavefront. Second is the plane wavefront. So this is the plane wavefront. This is the wave normals, and this is the plane wavefront. This is the wavefront, and this arrow is the wave normal. And third is the cylindrical wavefront. This is the wave normals. So this is the cylindrical. This is the wavefront, and this is the wave normal. Okay. So these three types of the spherical wavefront. So the spherical wavefront, when the point source, this is the point source. So when the point source in a isotropic medium, there is the medium required, isotropic medium, it sends out, the source sends out waves in three dimensions, where the source emits the radiation or the light waves in the three dimension. The wavefront are spherical and centered on the source. That is, this is the spherical wavefront, this is the source, and it emits the light in the three dimension. So that type of surface observed. So this surface is the spherical, and this is known as the spherical wavefront. So such type of wavefront is known as the spherical wavefront, and this is the wave normal. Then second one is the plane wavefront. So when the small part of spherical or cylindrical wavefront originate from a distant source, means this source has the less distance from the wavefront, but this source is at the infinity distance, means distant point. Okay, infinity source, like infinity. So then the wavefront is obtained, is known as the plane wavefronts. For example, rays coming from the infinity, like sun. So the sun is the distance at infinity. So that's why rays emits from the sun is the plane wavefront. We are getting the wavefront like plane. Then third is the cylindrical wavefront. So when the source of light is linear at the point equidistant from the linear source that lies on the surface of the cylinder, So such wavefront is called a cylindrical wavefront. So these are the three types of wavefront which we observed. First is the spherical wavefront, means the source is at the limited distance. Plane wavefront, source is at the infinite distance, and cylindrical distance is the source is the linear. So that's why cylindrical wavefront observed. So then the definition of wave normal. What is wave normal? Wave normal. So what is the definition of wave normal? Wave normal, as we see the diagram. So from the diagram we have the idea, that is this is the line drawn from the source. Okay, at any point, line drawn from the source, drawn to the source from any point. So this is called the wavefront. So exact definition is the perpendicular drawn to the surface of the wavefront. The perpendicular drawn from the surface of the, this is the surface, wave surface or wavefront. So the perpendicular drawn from the wave surface or the surface of the wavefront at any point. We are taking any point. Here the number of points are observed at any point of the wavefront in the direction of propagation of light. So this, where the light emits, where the direction of propagation of light is, so that type of direction is the wave normal. Means the perpendicular drawn, from the surface, at the surface of wavefront at any point the perpendicular drawn to the surface of the wavefront at any point of the wavefront, at any point of the wavefront in the direction of propagation of light wave. In the direction of propagation of wave. In the direction of propagation of light wave here. Light wave is called wave normal. According to name, we are getting the definition normal, that is the perpendicular drawn from the surface of the wavefront at any point of the wavefront in the direction of propagation of light wave. It is called the wave normal. So this is the definition of wave normal, and these are the three types of wavefront. Okay, so I hope all you understand what is the wavefront and what is the wave normal. Then in the next class we are seeing the then the next topic is the properties of wavefront. So as we see this discussion, so what are the properties we observed? First property is the wavefront is the surface in the medium through which the light propagates. Wavefront is the surface in the medium. Second property is the light wave travels perpendicular to the surface of the wavefront. The light wave travels perpendicular to the surface of the wavefront. Then third one is the energy of the wavefront is propagated in the direction perpendicular to the wavefront. As the light wave travels perpendicular, then the energy is also traveled perpendicular. And last one, the ray of light from the plane wavefront are parallel to each other. The ray of light in the plane wavefront are parallel to each other. This is the ray of light. So this is the parallel to each other, and radially diverging rays represent the spherical convex wavefront, and radially diverging rays represent the spherical convex wavefront. Okay, so these are the four properties of wavefront. So in the next class we are seeing the Huygens principle. Okay, thank you.